Okay, we look like we're in business. Look like we're in business. Hang on a second, let me just get my framework up in correctly. Okay. Okay. Pan back. Now, one of the things I noticed earlier, I did a video and all it looked like it was all on screen. When I ran it back, it was half the top was missing, and I don't actually know how that came about. But to make sure I minimize that, I'm going to pan back once I've started and finish. Okay. Okay, let me just go back to where I am and count my instructions. Right, series and parallel circuits continued, and you would look at that from the perspective of some continuation work that I've done already, which you will see on my channel. Okay. Here we're looking at understanding the relationship between resistance, resistivity, voltage, current, and power. Okay. Pure revision here. Okay, I don't need to do anything further on this. Electricity is considered to be a flow of electrons. Current is the rate at which electricity flows around a circuit. Resistance is measured in ohms and its symbol is the omega. Electrical resistance is a measure of the degree to which an object opposes the passage of an electric current. Each material has its own specific resistance. If the material changes in size or area, it will change its resistance. P rho is the symbol used for resistivity. Any electrical circuit requires three things: a source, a load, and a means of transmission. The source provides an electromotive force, or EMF, to the circuit. George Ohm discovered that the resistance of the conductor is linked with the voltage to the current. Okay, pan back, make sure that I can get that in because I do not want you going over my head in any shape or form. Okay. It's alright, you gotta talk to camera sometimes, you see, because it never does all this blinking told. Okay. And here, for me, this is session 5, series and parallel circuits. In this session, the student will have the opportunity to apply Ohm's law to series and parallel circuits. Okay. Series circuits. Now here we have when more than one resistor or load is connected to end, then they are said to be connected in series. Here we have 1, 2, 3, 4, 5 resistors connected in series. R to the N simply means any number. Okay. Here are your codings. Okay. Your codings. Here we have brown, black, red. Okay. Now I don't remember the colors offhand directly, but I think brown is 1, black is 0, something or the other, and red is 2. But don't hold me to it. I'm just spouting off. It's up to you to make sure that you investigate the color codings correct and that you know the values for yourself. Okay. There we are. Okay, again, similar thing you would have seen earlier in the other session. Okay, except that this is just recapping on it. Okay, so we're just simply doing a bit of recapping. And similar thing here as well. Okay. And here they're just showing you what they did to get resistance total. Okay. And in series, the resistance is the same in any component. The current is the same in any component. Apologies, the current is the same in any component. So I was thinking something else for a moment there then. Parallel circuit, okay. You're familiar with this, so I don't need to spend too long talking to you on this, okay. Well, my apologies again. I have to assume that your new parallel circuit is one where all resistors have the same voltage across them, okay. In a parallel circuit, the voltage across the loads are constant, and it is the current that divides. Voltage applied to each resistor in a parallel circuit, irrespective of the size of the resistor, is the same. Okay. Current flowing in a parallel circuit. Okay. And here, the total current is the sum of the current in each of the legs in the network. Okay. So the current would be R1, R2. The voltage across the circuit, the parallel circuit, is the same, but the current in each case will be different. I don't think we can ever do enough on Ohm's law, and that is important to keep that in mind. Okay. I equals V over R, or I equals U over R. Okay. V for me is old fashioned. Okay. But U is for you because you're now young and up to date. Okay. Multiple choice questions. Okay. Make sure you have got these. Okay. Use the information given. Okay. Okay. Now these you can read for yourselves and make sure that they're quite large and so forth. Okay, thank you for your time. I hope you will find this useful. Have a good day. Bye bye.